rational zero theorem. If f of x equals a sub n times x to the n plus a to the n minus 1 times x to the exponent of n minus 1 plus the rest of the terms all the way down to a sub 1 times x plus the constant a sub 0, then the possible rational zeros for the function will be the fraction plus or minus p over q, where p is the factors of the last number, a sub 0, and q is the factors of a sub n, which is the leading coefficient in front of the highest exponent. Title of the first section is List the Possible Zeros. In this section, we'll look at polynomial functions and list the possible zeros, which would be zeros for the function. First function we'll look at, f of x equals 2x to the third power minus 11x squared plus 12x plus 9. To list the possible zeros, we'll first find the value of p and find the value of q. Looking back at the previous definition, p again is the factors of the last number, a sub 0. In this case, the number is 9, so p will be 9 and all the factors or numbers that divide into 9. 3 is a factor of 9, and also 1 is a factor of 9. All the numbers that divide evenly to 9. And q, looking back at the definition, is the first number, the leading coefficient in front of the highest degree. So q will be 2, but also the factors of 2, which would be 2 and 1. The possible zeros again will be a list of fractions that we can make with p over q. We'll start off with plus or minus, since it could be positive or negative fractions. Taking the first number p could be 9 over the first number q, which would be 2. So the first possible zero would be 9 over 2. Second value, we can also use 9 over the second value of q, which would be 9 over 1, or just 9. Continuing on, we'll take the following next value of p, which is 3, and list that over both q values, which would be 3 over 2 and 3 over 1. And the last possible zero, the last p could be 1 over 2, or it could also be 1 over 1, which would just be 1. So the list of possible zeros, all the possible fractions, could either be positive or negative. 9 over 2, 9 over 1, 3 over 2, 3 over 1, 1 over 2, and 1 over 1. And again, these are possible zeros, which means some of these are zeros, but some of them are not zeros. And last function we'll look at, g of x equals x cubed plus 8x plus 6. And again, to find the possible zeros, we'll find the value of p and q, and then list out the fractions. P again is the last number, the constant 6, and all the factors of 6, which would be 3, 2, and 1. And q is the leading coefficient, or number in front of the highest degree. In this case is 1, and the only factor of 1 is 1. So the list of the possible zeros, again, each possible zero could be positive or negative, plus or minus. And since we only have one q value, we'll have the values 6 over 1, 3 over 1, 2 over 1, or 1 over 1, or 6, 3, 2, and 1. And again, these could be positive or negative. So we'll have positive 6, positive 3, positive 2, positive 1, but we also could have negative 6, negative 3, negative 2, and negative 1. Title of the next section is Find all of the rational zeros. In this section, we'll continue to list the possible rational zeros, but we'll actually find the zeros that work for the function. One definition for this section: number of zeros is the degree. For any function, the number of zeros for that function is the same as the degree. And if you remember, the degree is the highest exponent for any function. First function and only function for the section: f of x equals 2x to the 5th power minus x to the 4th power minus 2x plus 1. Again, for this function, we'll find all these zeros. Looking at the degree total, we have x to the 5th, so that means this function has a total number of 5 zeros. They could all be rational zeros, or some of them could be rational and some could be imaginary. But for this section, we'll find just the rational zeros, which could be up to 5 zeros. First, we'll list off the possible zeros by listing the p's and the q's. The last number, again, constant 1 would be p, and the only factor of 1 is 1. And q, the leading coefficient, number in front of the degree, would be 2, and the factors would be 2 and 1. So listing out the possible zeros, could be positive or negative, 1 over 2, or 1 over 1, which would be 1. So the possible rational zeros, positive 1/2 and positive 1, and also negative 1/2 and negative 1. And again, some of these will be zeros and some of them will not. To determine which ones are the correct answers for the question, we can take these numbers and divide them into the expression. If they divide in evenly, they're a zero or a factor. If there's a remainder, then it's not the answer. For example, if we do synthetic division, taking our first number, which is 1/2, we can divide 1/2 into the function to see if it works as a zero. The coefficients will have 2, negative 1. There is no x to the 3rd in the function, so we'll have 0x to the 3rd, and also 0x squared, and then negative 2 and negative 1, or negative 2 and positive 1. And again, using synthetic division, we can divide. If there's no remainder for this function, or for this division question, that means 1/2 will be a 0. If there is a remainder, it means 1/2 is not a 0. Dividing, we can drop the 2 down, and multiplying by 1/2 each time. 2 times 1/2 would be 1. Adding straight down would be 0. Multiplying by 1/2 would be 0. Adding is 0. Multiplying again and adding is still 0. Multiplying by 1/2 is 0. Adding this time is negative 2. And 1/2 of negative 2 would be negative 1. And adding, we'll have our last number 0, which means the remainder is 0, which means one of our zeros would be 1/2. Keep in mind we want to find all the zeros, which is up to 5 zeros, or all the possible zeros that work for the function. So we'll continue to do division using the other numbers that we have for p's and q's. For the rest of the problem, if you want to, you can continue dividing the original function, or when we have a 0, we can divide using just what's left over. For example, we can draw another box, use the next number, which is positive 1, and divide 1 using the coefficients that we have left over, not counting the remainder of 0. So the next problem, we'll divide 1 into our other coefficients. And again, if this works, we'll have no remainder, and 1 will be an answer. If we do have a remainder, then 1 is not an answer. Dropping the 2 down again. This time we'll multiply by 1 for each question. 2 times 1, adding 2. 2 times 1 and adding 0. 2 times 1 and adding 0. And 2 times 1, negative 2 plus 2 would be 0. And again, a remainder of 0 means this is a factor or 0 of the question. So positive 1 also works as a 0. And again, to continue the question, looking back at our positive zeros, we have 1/2 and 1 over 1. Keep in mind they also could be negative, so we'll check negative 1/2 and negative 1. And again, each time you get a remainder of 0, we can use the other numbers left over as the function to see if the other zeros divide into that also. So the next number we'll check, instead of 1/2, we can check the negative numbers, which would be negative 1/2. And again, if we have a 0 for a remainder, that means negative 1/2 is a 0 or a factor. If we get any other number besides 0, it means negative 1/2 does not work for the function. Dropping the first number down, we'll have 2. Each number will multiply by negative 1/2 this time. Negative 1/2 times 2 would be negative 1. 2 plus a negative 1 would be 1. Negative 1/2 times 1 would be negative 1/2. 2 plus a negative 1/2 would be 1 and 1/2, or you can write it as 3 halves. Negative 1/2 times 3 over 2 would be negative 3 over 4. And 2 plus a negative 3 over 4 would be 1 and 1/4, or 5/4. And again, if this was a 0 remainder, that would be negative 1/2 is a 0 for the function. Since we have a remainder, a number that's not 0, that means negative 1/2 is not a 0 and does not work for the function. And the last possible 0 that we'll check is negative 1. Again, for this question, we can use the last answer that we had with the remainder 0. So the 4 2's we can bring down and see if negative 1 divides into it. We cannot use the numbers listed above since the remainder was not 0. And again, for this question, the last possible 0 that we have, if we have no remainder, this would be a 0. If we have any other number that's not 0, then negative 1 does not work. Dropping the 2 down, negative 1 will multiply for each number. Negative 2. 2 plus a negative 2 would be 0. Multiplying by negative 1 would still be 0. Adding will be 2. And negative 1 times 2 would be negative 2. Adding will get a remainder of 0. Again, if we have a remainder of 0, that means negative 1 is a 0 for the function. Since we went through all the possible zeros, 1/2, 1, negative 1/2, and negative 1, the 3 that worked was 1/2, 1, and negative 1. So for this function, we have 3 rational zeros. Those zeros would be 1/2, 1, and negative 1. We did have a degree totaling of 5. So since we found 3 zeros, the other 2 left over would be imaginary zeros. But these are the 3 rational zeros for the function.